completely unrealistic anymore. It's a bit chilling. Quotes Gamaval. Quotes like this and several others on artificial intelligence sends a chill to my spine. I'm sure many among us feel the same. Today, we are fortunate to have an eminent personality from the world of artificial intelligence amidst us to give us a clear picture of artificial intelligence and its impact on human society. Chair on the dais. Dear audience, please put your hands together as we welcome our honored guest.
Dear audience, I take immense pleasure in introducing the guest of the day, Professor Ramamohanarao Kotagiri, who received his BE from Andhra University, ME from Indian Institute of Science, and PhD from Monash University, Australia. Professor Mohan Rao was awarded the Alexander von Humboldt Fellowship in 1982. Being appointed as a professor in computer science, he was at the University of Melbourne for a period of 4 decades from 1980 to 2020. He held several senior positions including Head of Computer Science and Software Engineering, Head of the School of Electrical Engineering and Computer Science at the University of Melbourne and Research Director for the Cooperative Research Centre for Intelligent Decision Systems. Professor Rao served on the editorial boards of the Computer Journal, Universal Computer Science, Data Mining and VLDB Journal. He had been the program co-chair for VLDB and several other conferences. He is a steering committee member of IEEE, ICDM, PAKDD and DASFAA, and also received awards from these bodies for his distinguished contribution and service. Professor Rao is a fellow of the Institute of Engineers Australia, Australian Academy Technological Sciences and Engineering, and of Australian Academy of Science. He was awarded Distinguished Contribution Award in 2009 by the Computing Research and Education Associations of Australasia. He graduated 80 PhDs, supervised more than 30 postdoctoral fellows, published more than 600 research papers, and received research grants in excess of $60 million. Sir, we are glad to have you here today at our premises. Dear audience, let's put our hands together as look forward to hearing from Professor Ramamohanarao. Thank you.
My name is Ramamohanarao Kotagiri, but in Australia they would struggle to tell my name. So I chopped and I left Rao as my name. And I tell them, whenever they call me Rao, they're calling me Sir, which is kind of insulting them. So today I'm going to talk about importance of artificial intelligence and impact on society. So how many of you speak more than 3 languages? Okay, more than 3, right? So 4, at least I know. Okay, there are lots of them, it's good. All right, so my talk basically gives you some kind of motivation and some of the interesting research issues that we face in artificial intelligence and some of the big breakthrough applications in AI. For example, artificial intelligence have solved some important problems that people thought could never be solved in our life systems, but they did. And the blue stuff, probably I won't talk it because it's too technical, so I'm not going to talk about that. But I do mention it, why that is important future. And the next thing is that any systems we build, they have to be trustworthy and secure. And that's a very, very important problem. Trust means that we can rely on that. Suppose, let's say, if you go on an airplane, you have to be trustworthy. It won't, drop in the middle of the flight. You will reach your destination. And security, in the sense, with information technology, one of the things we want to do is that we don't want to give unnecessary information to anyone else. Like, for example, either your medical information or your whereabouts. One thing I found in India is that people are incredibly reckless with their phone numbers, they travel, they don't seem to know what impact it has in the future about their lives by just releasing this kind of information. And then I'm going to talk about how AI systems can be made robust from attacks. Attacks that means people can misuse this technology and then make you do something. So for example, with the AI systems, it is possible that you can receive a phone call and the phone call sounds just like your mom or dad speaking to you. You cannot tell it is not your mom or it's not your dad. Suppose the call comes, it's actually wrong. Somebody managed to make you a call that sounds just like your dad, and therefore you believe it. So this is what the attacks means, because that could be quite dangerous. Okay, next slide please. Okay, so one of the goals that we have in all our sciences is that you take some observations, some data you see, right? And from that data you wanted to tell some interesting stuff that you want to learn from that looking at the data. So for example, in olden days, like Copernicus, Newton, during that time, people used to look at the planets. They used to look at the stars, suns. They used to see the motion of these things, and they observe the angle, where they have seen relative to their positions and time, how long they have seen. And they found that there must be some physical law that matches with our observations. So for example, why we see happening rain at one particular time of the year, why it becomes hot at a particular time of the year, and it seems to be very regular patterns. And you wanted to know from a science point of view what makes these things to happen. Why would we see rain usually, let's say, in August, September, October time? Why it happens every year and year? And occasionally, of course, we have failures, but generally you see a regular pattern, and you wanted to understand these things. So the idea here is that by observations, you kind of build some knowledge. So once we have the knowledge, then you wanted to use how to use the knowledge. So for example, let's say we have knowledge how to make use of nuclear power. We can make power plants, nuclear power plants, or we can use nuclear for treatment of diseases, or we can use nuclear power for wars. The question is that the science only tells you how all of these things work, but how do we use that information is what we call knowledge or wisdom. So the wisdom is the one, how you use the knowledge is the wisdom. So usually, we have politicians or social scientists who might say we should not use nuclear bombs because it's not going to do any good to anyone. Even if somebody drops in one place, it doesn't mean it's not going to hurt you. You never know which way the winds and the radiation will spread. So there's lots of wisdom will be there. Like for example, when we had COVID or coronavirus, you have this knowledge that we can build vaccines to treat them. But the question is that we know how to build a vaccine, but we need to convince people to take it. There are people who don't believe in these vaccines and they don't take it, and a lot of them died as a result. And the problem is that sometimes you have some knowledge, but sometimes the knowledge is not enough. Sometimes, for example, we never would be able to build, medicines that cure perfectly. You never know, because human physiology is so complex. You don't really know how these things work. So the wisdom is the decision of how you make use of your knowledge. Okay, like for example, you study economics quite a lot, right? People will have this idea. If you reduce the interest rates, then people will be able to, do better business. But then there's also other side. If you reduce the interest rates too much, then people start spending a lot of money, and therefore prices will go up. So the question is, what is the right kind of things to do? The economics will tell you. But the politicians are the ones who actually need to make this decision, whether you have a highly regulated economy or something market driven. So these are the kind of issues that people have to take. So for example, in China, it is generally centrally controlled. Whereas in the rest of the world, it is always market driven, supply and demand. So there's always pros and cons among these kind of things. This is what the wisdom comes in. Next slide, please. Okay, so remember I told you that every invention that you have ever seen is always based on some observations. So for example, Newton's laws, and they measured how the planets are moving, and then they tried to come up a mathematical model to study this. And then Newton came up with Newton's laws. How many of you heard Newton's laws? Okay, lot less than the models, and then you build a theory and then see whether the theory agrees with the data. And when it agrees, then we believe this is the kind of data we have. So people make jokes. So like for example, two scientists, one a biologist and one physicist. They are very good friends. They always go together, and they always have lunch together. One day, the physics professor was trying to convince the biology teacher, do you know why apples, when it falls from the tree, it always hits the ground? And he wanted to explain to them Newton's laws of gravity, and then trying to give the formulas, at what acceleration is going to hit by the time it hits the ground, what velocity it has, and how much force it has. All of these things he was telling to the biologist. Biologist said, "Oh, we have a much simpler explanation why apples fall down." And what he said is initially, Darwinian theory, right? Evolution, if you know. So what he said is, well, once upon a time, apples were going everywhere. Some come down, some fly up, go everywhere. But the ones that hit the ground survived. Everything else is gone. And therefore, evolution said only the apples that fall down can only produce children, effectively. So that's a kind of model a biologist has. Of course, that's wrong. So the question here is that we have, the information, the data we are collecting is growing exponentially. Exponentially means, every time it's doubling or going with some phenomenal speed. Exponential growth can't be forever because it goes to infinity very quickly. But they grow very, very fast. But the actual knowledge from this data that we have, all these observations, is going very flat. That means our knowledge itself is not large. But what we should be doing is along this green line. That means our knowledge should also increase kind of exponentially, but not as fast as the data we collect. So this is the goal of artificial intelligence, is to build systems where the knowledge can grow in this angle rather than staying like this. Okay, next slide please. So what is artificial intelligence? Is anybody has an idea what an artificial intelligence is? Hands up. Okay, well I try to give you a basic things. There are effectively two ways of making computers to do what we want us to do, what we would like them to do. One is basically instructing, writing programs or coding in such a way it behaves the way we want. It's almost very similar to like baking a cake. If you ever look at your mom or dad, if you ask them how to make a cake, they will give you a recipe. They say, well, first you need eggs, you need some flour, and you need some butter, maybe some milk, some sugar, and then tell you first, okay, first you crack the eggs, instruction 1, and then instruction 2, scramble them or mix them well, and number 3, they say mix with flour, some wheat flour or something, and you basically give instructions and you follow. At the end, you put them in the oven, and then you get the cake, right? This is instruction by instruction. And you can write the computer program exactly the same way, just instructions. Add these 2 numbers, multiply by this number, and then add this. Let's say, for example, you want to do your income tax calculation. You say, well, your income is this. Then you say, okay, first, I don't know the rules here, but let's say, first $20,000, you don't pay any tax. You take that money from your original account. Then you say, for next $30,000, you will be taxed at 20%. You take that money. And the next 30,000 you will be paying at 35%. And once you reach 200,000, you start paying 50%. Every dollar you make, you pay 50% of that dollar, 50 cents. Okay, if it is rupees, then rupees exactly. So it's basically instructions. You can write that instructions in the computer language, whatever the language that you are comfortable with, you can write that, and the computer does that. You know, you say, okay, now I made 20 lakhs. Tell me how much tax I have to pay for the Indian government, and you give that number, and then you end up with how much tax you have to pay. So this is based on instructions. And the second way is we don't really know how to instruct the computer, but all I can show is show examples, and from the examples it wants to learn. So one way to do is like, let's say you have a small child at home or something. You show the child, this is a horse, this is a dog, okay, this is a cat. That's all you say. But somehow the baby seems to recognize these animals implicitly, right? And they know this is mommy, this is auntie, this is daddy. So this is how they learn. The question is, these are not instructions. Somehow they are learning by examples, by simply showing examples. And that's why even today, when we do even a good mathematics or good physics, we always give examples because they reinforce, they make them understand how exactly those maths work for them. But in here, we don't have any mathematics at all. All we know is examples we have. For example, let's say you take a medical example. We have done all of these tests and the person is suffering from, let's say, diabetes, or I found all these observations, this person is basically suffering from leukemia or so whatever diseases are. And we can't really write a rule saying that if this happens, if this happens, if this happens, then this is most likely the kind of disease, which is maybe not always easy to capture every possible disease. Sometimes what happens is there will be entirely different diseases, symptoms would be very identical, tiredness, high temperature, no appetite to eat, everything is same, but in one case is one disease, another case another disease. So we may not have enough information available to actually tell what it is. So we can't really do it. And this type of computing is called machine learning or artificial intelligence. That means we don't have a procedure to do something and still we want to solve those kind of problems. And that is basically what AI is. Okay? This trend is expected to continue. So what I wanted to say is that the many interesting problems that we can't do, we're going to use this approach, basically applying these technologies. And the other thing is that once I was talking to the director of Microsoft in China, and he was telling me that the companies who are going to be very rich are the companies who have information. So for example, Google will be there for a long time. Microsoft may be questionable because they don't have as much information as Google would have. Facebook has huge amount, all your lives are documented in Facebook. Twitter, all of these companies will be the richest companies for many years. For example, the more data I know about you, I can tell exactly what you want to eat, who you want to be friends with, who you don't like. Sometimes it's even possible to predict what kind of diseases you're going to get. All of these things, people say, Google search engine knows more about you than your mom and dad. Because the kind of queries you make, the way you use the computer basically knows more about you than these things. And all this is happening because of this second one. That is, we can learn behaviors or models by simply observing the data itself. And this is what scientists were doing for millennia, like Newton. All of these people looked at the observations, tried to come up with a theory or a model that can explain the data. And that's what research is, that's what science is. Next slide, please. Okay, suppose let's say I show you this data. Does anybody understand the graph? Basically what it means is for this value somewhere, for this input, that's the output. If you give this, it's 0. If you give this value, it's 1. Right? Can anyone tell me what this function might be? Have you done trigonometry? Has anyone done trigonometry? Okay. Do you know sine cos functions? That is a sine function, right? Because sine 0 is 0, sine pi over 2 is 1, sine pi is 0, and this is 1.5 pi is minus 1, that is 270 degrees. Again, if 2 pi is 0, and it's a periodic function. Suppose, let's say, you never heard of trigonometry, you never heard of this function. Then somebody throws at you, this is the data I found. So for example, do you know what a pendulum is, right? And what you can do is you can kind of see the pendulum height, for example, where its position is with respect to time. Okay? Then you can tell at certain time or certain angle, its height is highest and then lowest at this point, and then goes in the other direction and comes back to in the middle and then goes to the rightmost position. So the pendulum itself is a sine function. Okay, if you did a little bit of maths, you will see that. But the question here is that in the absence of no knowledge, can machine learning or AI can predict what this function is? So for example, this is the y value. Given y value, I wanted to know what x value is. So this can be learned by simply looking at the data. A lot of data you give, the machine can come up with a relationship between the x coordinate with the y coordinate. So that's given y value, we need to predict x value. Next slide, please. So in this case, what I want to say is the function that I needed to predict is it so happened inverse of sine function, which is arc sine theta, right? So this is a theta value. You can see pi, 2 pi, 3 pi. So if you give the value, then it gives you the value. You give the value, then it gives the. So you give this value, and then it gives you the x value. So this is what machine learning it tries to do. That is, from the data itself, it discovers this function f of y happens to be arc sine. But the interesting thing is the computer doesn't know it is actually inverse of a sine function. But it basically discovers that function and does that for you. Next slide, please. Okay, so before I gave you sine function, but I have a new data now. I have this picture, I have this picture, I have that picture. Oh, sorry, this has to be in this box for a minute, okay? Somehow when we transferred slides, mine is Apple and that's probably not Apple, and sometimes the formats get a little bit jumbled up. So in this case, what I needed to do is I needed to find a function. Somehow I give a picture, it has to tell who this person is, right? Previously, from a mathematics point of view, you can say what function is closest to this data and then you can do it. But it is almost impossible to instruct a computer to recognize a human face. It's impossible. We don't really know how exactly human brain works. When I see, for example, I see Dr. or Mr. Vasugaru, the moment I see him, I'll recognize him, but I can't tell exactly what makes me to think that he is Vasu, right? So how somehow our brain does that. We don't know what process that takes place in our brain to recognize these things. And similarly, let's say you all speak more than one language, right? So I speak something in English, you immediately can translate into either Hindi or Tamil or Sanskrit or whatever languages you know. But you can't really explain exactly how the translation is taking place. Nobody knows the rules. You have some approximate rules, but usually they fail. Most of the time they fail. So the whole machine learning is that how to find these functions. That is, how you can find the relationship between two different kind of domains. In this case, this domain is the picture, and the other domain is the name of the person. So I needed to discover this. So now we can build programs using machine learning that recognize pictures better than human being. So, for example, every year there's a huge competition who can do best facial recognition. So if you have, I think many phones these days, especially I know Apple, right? They recognize you. But that's a lot easier because it only need to recognize you, not anyone else. They can simply measure your picture, various kind of things, and they do. They don't really do amazing facial recognition, but they can recognize your face very accurately and then not recognize anyone else, which they can do. But the real question is that given any of these objects, you should be able to recognize who they are. So do you know all these three people? So this is Newton, and of course I written there, Einstein and Darwin. These three are my most favorite scientists. Even though I'm a computer scientist, these are the most amazing people. They produced science, beyond limits. For example, Newton is the first one came up with Newtonian mechanics, and we can build aeroplanes, we can build all structures, we can build cars, everything, even predict where the planets are, even where the stars are, we can predict. But then came Einstein and he said, well, Newton is not exactly correct because he assumed space and time are independent. That is, time has no impact on space. Your X, Y, Z. See, I'm here. You can say, okay, you are in this building, in front of the auditorium, and sitting in front of you. You can give me all coordinates of mine. But the time is also independent. You can say, okay, Rob was here at this time, and then a few minutes later he moved here. So various time things you can do a trajectory of me and then tell them. This is what Einstein assumed. Newton assumed. And Einstein came back and said, well, it's not that simple. If I'm moving very fast, then these XYZ coordinates somehow gets changed. They have interdependency. That is, time and space are not independent. They are entangled together. That's why they call space-time problems. So since then, Einstein developed a whole theory of general relativity to explain what acceleration is, how gravity. So basically he had a theory of gravity, basically. And he told that it's the curvature in the space-time object. You need to learn a lot of maths to understand that. So I'm only using a kind of buzzwords for you to appreciate. The space-time is the one that gives you gravity. So that means whether you are on a planet, I weigh something. Suppose, let's say I go onto the moon, my body weight will be 1/6. But if I go on Jupiter, my weight probably 3 times more, right? But you can get exactly the same thing if you're accelerating in an aeroplane. If I go very fast on an aeroplane, let's say you sit on a rocket and go, then I can appear to be going, sitting on a big planet 6 times the weight of a Earth, for example. If you say your rocket is going at 5G, that means you're feeling as if you're sitting on a big planet about 5 times bigger than the Earth, because it says 5 times the gravity. So whenever you go on that's why when you see in the movies, when these people are going, the face, all the muscles will pull down because of the gravity. The bones will come out, and you get these ugly faces because of the gravity acting on you. And that's what Einstein did. And of course, Darwin was another amazing scientist that he could tell, we are not created by God, but we are created by simple evolution, right? And amazingly, some countries don't allow Darwin's theory to be taught. I think in Pakistan, you're not allowed to mention Darwin's theory of evolution. They do indirectly, but because it conflicts with the religion. And sometimes we have problems, like, Galileo was put in a house arrest because he said Earth is not the center of the universe. At that time, in the center of our system is sun. We all go around the sun, but at that time, Christianity believed sun was going around the earth, right? But then they couldn't explain the motion of other planets, and then finally he's the one said, sun is our center of our system, and we go around the sun, and they didn't like it. Pope didn't like it. So they put him in a house arrest for many, many years. Only I think the Pope Paul is the one who basically said that they made a mistake. No other pope ever discussed that. And I think Galileo actually died house arrest. So many scientists feared to talk about some of these sciences because it was contradicting with religion and beliefs. And we have these problems even today. Like some people don't like to take vaccine. They think it is against their religious beliefs. But the amazing thing of Darwin is that he was able to explain how we evolved with time. And of course, there's always gaps in science. One thing you should remember is the difference between a religion and a science is happy to change its views as we learn more. Whereas religion doesn't, always stuck at whatever they believe. If God created us, and that's the belief we have. And of course, in physics, we believe that everything started with Big Bang, and nobody knows why Big Bang happened. Nobody can explain to that. Time started at the time of Big Bang according to physics. Everything, matter, everything started at the time of the Big Bang. But we can't tell why that happened, from a science point of view. But from that event, we can explain everything else, how the black holes happen. Everything is predictable to very, very accuracy. And the amazing thing is, Einstein, when he did that work, we don't have instruments to actually verify his theory is correct. He died about 100 years ago. Now we know that everything he said, every part of his theory is absolutely correct. We haven't found even a single correction. So is Darwin's evolution of theory. What it says is that any species survives provided the environment is compatible to that species. For example, if there's a huge starvation, ants will survive, but elephants will die. So this is that's why when we have a huge asteroid hit the Earth, all big animals wiped out. All the dinosaurs all just wiped out because they needed more energy. Anything that needed more energy or more food are the first candidate to die. So people who are very thin will live longer. So next slide, please. So the most important thing is that in any country to do well, you need to collect a lot of information. The more information you have, you can do better decisions. Like in Western world, every planning they do is based on available information. More information you have, you can do better decisions. So, for example, many of these chaotic things we were able to manage well because of the information we collected. Next slide, please. Again, the diversity of data, like for example, this is the astronomy, this is stock exchange, this is agriculture, this is some entropy, this is some some ancient pictures and the flora, and then the human physiology, MRI, and then again radio telescopes. All of this give you different kinds of information, and you need to know how to use that information to discover some new results. Next slide, please. So from a computer scientist point of view, we have lots of issues that we have to deal with. One is how do you represent this information so that it's useful? So for example, how many of you use Google, right? Google search engine. And what you don't know is that how they store this information, how you are able to process this information. If you make a query, let's say I type Mahatma Gandhi, all of a sudden lots of articles will come, right? And similarly, if you're interested in movie actors who I don't know any names, let's say I'm exposing my age as well, N.T. Ramarao as a movie actor, so you get information about him, right? Similarly, if I wanted to know general relativity, I type general relativity, huge number of articles would come. The question is, how is Google doing that? It's going to process several billion requests a day, and at any given time, several 100 million queries would be taking place. How are they handling this? How they store this information? How they process that information? They use, maybe today, several 100,000 computers running all the time, 24 hours, non-stop. Even if something fails, still some part of the system works. So we build very complex systems to do that. And that's what the database modeling is, how to store information, how you were able to process information, and so on. And then the other thing that's challenging is that you have various kinds of information. So for example, let's say you are in the business area. You wanted to know what people's interests are, where they go, where they move, what kind of things they buy. So you have different kinds of information. You need to use all that information to make business decisions. Or even governments, for example, what is important for people? Is it water quality or the water? How much money should I spend on the roads? How much money should I spend on clean water? How much money should I spend, stopping industries near where people live? How much farmland we should use it? How much farmland we can destroy it? All of these questions, can we use fertilizers? Can we use chemicals? All of these are different kinds of information. How do we use that to make better, either government decisions or business decisions? And then many other issues of machine learning is there are many issues for machine learning as well. So for example, let's say I want to build some amazing computer game. I can use AI tools to build that. But then I know so much about physics. So for example, let's say you have I'm sure a lot of you play computer games, and you see that humans moving in that place, right? It should look very natural, as if they're walking on an earth, not like jumping and dropping, and it looks like very jerky motion. So basically you want to apply physics, like Newton's laws you want to model. And Newton's laws need to be modeled with the AI, and that's what we call how to incorporate domain knowledge into these things. And similarly, we know so much about medicine, and still we don't know a huge chunk. We want to combine these two things together and then actually build very useful systems. From a computer science point of view, if you sit in a car, you know that car, how many people it can take. You say, well, it is safe to keep 5 people in a car. Anything more is not designed. So when I design a car, I design the car for certain maximum load. Maybe 5 people, maybe 200 kilos of weight, nothing more. But if you keep much more than that, you're taking risk, because the car can break down, tires can puncture, or if the brakes don't work because you have too much load on the car, and if there's uphill, it won't go up. All of these issues will come. And this is, we call them design specification. You designed a system for a particular purpose, and therefore we know exactly how it goes. So for example, if you have an airplane, the pilots would compute how much fuel I need. So for example, let's say I'm flying from here to Australia. We know the distance. The distance is about 12,000 kilometers. So I know how much fuel the airplane needs. But on that day, there could be winds against the airplane, in which case you need more fuel to take with you, because the air friction is too much. And similarly, if there are too many people in the airplane, then you need more fuel. More fuel means heavier the airplane, and therefore more fuel, right? So it's kind of, you need to do all these kind of maths. So at least we know exactly what they need, right? So this is what we say, somehow specifiable systems. That means we know its characteristics. Like aeroplane, I know exactly how much fuel you need to take. Occasionally what happens is, even on airplanes, they do all these maths, and once the aeroplane takes place, something happens, weather changes. Previously there is no wind against the aeroplane, but after you took off, after 2 hours, weather conditions changed, and there's too much air resistance. Or for safety, the aeroplane is instructed to fly at a certain level. At that level, there's too much air friction, and all of a sudden we don't have enough fuel, in which case you might have to land. Let's say I'm flying from here to London, then they might say, no, you better land in Frankfurt, and the people do that because they ran out of the fuel. So these are fully understanding systems. For AI, we don't have. For artificial intelligence, any system you build, I cannot tell how well this system would perform. I have an idea, it does very well, but I don't know when it's going to fail. So for example, in the airplane, I know if the wind velocities have changed, I should have to, fly to a nearest airport rather than going to all the way to London. Because if I do that, I'm taking a lot of risk because I will run out of fuel, the aeroplane will crash. So I have to, land somewhere much closer, like Frankfurt or Dubai, whichever nearest airport is. That's how they do it. And all these international allow you to land your airplane as long as it's not a terrorist situation. They do allow this. So we don't have, for AI and machine learning, mathematical way of telling how good these systems are. And this is an open research for AI because it does solve some amazing problems. So my research has been how to make these AI systems robust. That means they work well, they predict well. We need to be able to integrate some domain knowledge along with this good quality of the AI systems. Next slide, please. Okay, so first thing is the data is growing exponentially. The more computers we have, and the computers are becoming cheap. There's something we call the Moore's law. Moore's law means every 1.5 years or 2 years, the computing capability doubles. So that means what my computer can do today, from let's say in 2 years, the new computer for the same money will do twice better. So it is getting twice every time. This is called exponential growth. Every time if you multiply by 2, it's called exponential growth. Okay, if you say 2 to the power of 7 today, tomorrow 2 to the power of 8, next 2 to the power of 9. Any power is called exponential. Okay, so that's how the computations are going. So exponential growth of data and the speed of internet and many devices making us to collect a lot of information. Next slide, please. So here is some example, like human genome, that is the DNA. We're all made up of, interestingly, every human being is like a machine. We have a code in our body which is called DNA, and that determines our health, how long we're going to live, what kind of diseases we have. Of course, it also depends on our behavior kind of dictated by DNA as well. So basically DNA is what you are. You're like a computer driven by DNA program. So this DNA we can collect. In 2012, it would cost about $1,000 and it's going to be $100. And now if you have your DNA, they can predict everything about you. What kind of health problems we have, what kind of way you better live, because let's say if your DNA tells you you're prone to diabetic situation, that means you want to be very careful from the day one. Even from childhood, you'll stop eating chocolates, eating all sweets, but then sometimes you question what's the point of living if you don't eat chocolates, right? We have to eat chocolates. So basically this becoming cheaper, that means we can collect very much information. Let's say every Indian can go through one of these scans and you have a full information, and then they can give you what you have to do to live happily from that point onwards. Next slide, please. So this is the DNA sequence. It's a double helix made up of the nucleotides things, and these are the various kind of bonds. That's how it works. So I did a simple mathematical computation. There are about 8 billion people in the world, and each person requires a genome of several billions. So you have billions of data you collect, just DNA itself. And you have many other things, X-rays, MRIs, and so on. Next slide, please. So one of the things as a computer science we find is that we have so much information, and how do we use this information in a sensible way? This is a big challenge, because you're too young, you wouldn't know. There's something called curse of dimensionality. That what it means is, more features I collect about a person. Let's say I take a person's dimension. Age is one dimension. Let's say their gender is one dimension, male, female, and so on. And the third dimension is their age. Fourth dimension is, let's say, their height. Next dimension is their weight. These are kind of dimensions. The more dimensions I have, the problem becomes very, very expensive in terms of computationally. And this is we call the curse of dimensionality. So now we can build AI models with 2 trillion parameters. So for example, a parameter is a way of telling how good this model is. For example, if you look at a simple function like let's say x squared, y equal to x squared, right? So there's only one parameter that is let's say y equal to 2x squared. That's a function. The parameter is 2 and the function is called x squared together. And now we build, instead of 2x squared, you have, instead of one value 2, you have 2 trillion, that is 2 million things. So these are the kind of models that can be used to translate any language to any language. Now we have models that understand 43 languages. You can only speak 3. The computer can speak 43 different languages. In fact, there is no limit. It can speak all the languages, provided you can give the data to the computer. So now we have automated translations exceptionally well. So for example, a computer can write an article of 50,000 words, is almost like a book. And if I give you 2 articles, one written by computer, one written by human being, you would find it difficult to tell which one machine written, which one is written by a human being. So that's the level of amazing achievement made with the machine learning. So for example, until 20 years ago, we were writing computer translation by instructions. Let's say this is a cat. Then you say, oh, this means in my mother tongue I have to use this word. And then you say, oh, is a verb. So I have to use my mother tongue corresponding word. So this is how we used to translate a sentence into my mother tongue. But now we use machine learning. All you do is you show a text and it automatically understands the relationship between words, and then we can use that to train languages. So that's because we can build these huge complex models. Next slide, please. A GPU is a graphical processing unit. Again, if you do computer science, you would understand that, but I will do that. So as I said earlier, I don't want to talk about that. Machine learning, we have the scale, that is the amount of data, dimensions, how many features we collect. These are the big challenges for the things. And the other one is the how to discover these models that explain the data. This is what science is. You need to build some mathematics or some explanation to fit the data. So for example, every year you see eclipses, either solar or the lunar eclipses, right? And there's a complete mathematics to do that, right? The mathematics will tell you exactly when these events happen, how long these eclipses last, when they start, when they end. Is completely predictable. And that's because we were able to build the models that are able to explain these things. Okay, so this is the models, right? And that's what we're trying to do. And the machine learning, it does the thing. It builds a model, but that model we can't make any sense of it. It's a very complex network of values. All we do is multiply numbers, add numbers, subtract numbers, add numbers, subtract numbers, or 2 trillion of them we do continuously. But we need to do the whole discovery process is what these numbers are. How do you multiply? What number you want to multiply? How much? And that's what machine learning is, to find out the exact values that we needed to discover. And the most important thing is applications are unlimited. There is no area where machine learning cannot be applied. In a way, if you think, human being and computer is very similar in many respects. We all apply logic. We all apply some kind of a processing in our brain. Like when you see a cat, is something happening in your brain, some computation is taking place, and that's what we are. So computation is what the humans are. So there is a thesis called the Turing thesis. Basically what it says is that anything that is computable can be written in a computer program. That means anything that is computable means you can actually find the results using it, can be coded in a computer and to do that. And this is there is no a theorem to disprove any other way. Okay, so you can apply in commerce, you can apply in music, you can apply in art, you can apply in medicine, you can apply in engineering. There is no limit to application of computing and AI. Next slide, please. Okay, do you know what this game is on the left? It's called Go. You heard Go? Okay, it's called Go. Geo Go. And the other one is chess. What I wanted to say is, for a lot of people think chess is a very complex game to play. But Go is maybe even 1,000 times harder than chess, or even more than that, because the number of possible moves are so much larger than chess. So, for example, you have champions for chess. So now we have AI-based chess programs. It will beat any champion in the world. So it can build. And people thought Go would not be solved by a computer program for another 100 or 1,000 years. That's what people thought. Then Google built something called AlphaZero. It's a name of the AI program, built using deep neural nets. The deep neural nets are something similar to the way, not quite, but in analogy sense like a human brain. You remember I said 2 trillion parameters, that's the kind of network we built. And that can play this game and beat the best champion in the world. So now, no one can beat this chess program called AlphaZero by any human being. And people thought this would take another 100 or 1,000 years to build such a complex system, and we did that nearly 7 or 8 years ago. Next one, please. The next one is protein folding. This is we humans are made of proteins. Your muscle is a protein, your brain is a protein. When you're thinking, your brain is producing some proteins to interact. Protein is basically a primary sequence of amino acids. There's about 20 of them, amino acids we have, and our whole life is effectively explained by these amino acids. So initially we have a DNA. DNA makes RNA. RNA you make these proteins. And the problem with the proteins is that they have 3 structures. One is called primary structure, which means basically sequence, how they appear one after the other from a bond, from a chemistry point of view, how they bond. And the interesting thing is they don't look like a sequence. They have these shapes. This is like this is a helix, like a spring. These molecules like A1, A2, 3. You can see A1, A2. So A1, A2 has same distance as A1 and A3. And for example, A3 has all these molecules more or less same distance. Like A1 is similar distance to A2, A3 is similar distance to A5 and A4. And that information is not available in the primary sequence. Only in the secondary sequence we know how they are positioned in our space. And then there's called tertiary structure. They coil like a snakes on sheets. So here is like a sheet, like a piece of paper. The sequence is like a piece of paper, and this is called beta sheets. And the way the proteins interact is based on their tertiary structure. So for example, COVID vaccine is studied using these tertiary structures because we know how these spikes will be there, which is a tertiary structure. And COVID vaccine is basically producing those spikes in the vaccine so that when you take that vaccine, it looks like a COVID disease, and our body produces antibodies to protect you from real COVID. This is how we did that. Now they're saying that same technology may be useful to cure cancer. So a lot of people have huge hope that same vaccine technology might cure many cancer diseases. So the question I wanted to say is, going from there to there, is impossible. Nobody knows how to do that. So people spend their lives using something called crystallography. What it means is you have one of these molecules, and then you send X-ray beam and take a photograph. From that two-dimensional photograph, you try to predict what these three structures would be. So you take pictures in different models, different directions, and the scattered light gives you some information, and you try to predict what the tertiary structure would be. So for example, if I give you a sequence like that, to predict the tertiary structure, or sometimes we call them quaternary structure, that means multiple proteins interacting with each other, would take, like for example, a particular protein might cost you something like 50 million rupees or more just to do one, and it might take 6 months to 8 months. It's computationally very, very hard problem. We call them NP hard for those when you become reasonably mature in your maths. What it does is a non-deterministic polynomial. That means if you know how to do it, it's going to be let's say a quadratic function or a cubic function, assuming you know what they are. A complexity, that means how much time it would take to solve the problem. So for example, if I give about 100 atoms and if apply a simple procedure, the universe will extinct. It will take that long to find this molecule structure. But with AI techniques, we can do it very, very accurately now. And now you can do that in few hours rather than spending 6 months or 1 year to understand the molecular structure, in a three-dimensional molecular structure of these proteins. And these are important for us to build new drugs, to treat diseases, to understand the diseases, everything based on these protein folding problem. Next slide, please. So basically what happens is you give this sequence information, we train this thing called we call the deep neural net, and then bang, it produces the structure of the 3D structure. And this is, they say now, this was done about 2 years ago. This is going to revolutionize the whole biology, the whole medicine, the whole pharmaceutical industries will completely change because of this understanding of the structure that we can do. Next slide, please. So this is the work that one of my students did with me. So what we're trying to do is we take MRI, which is magnetic resonance imaging. That is, your brain can be taken an image using magnetic resonance. Again, this is a physics, and that from that signal we were able to tell connection between various parts of your brain, and we can also tell the function. For example, your health is good, you're thinking well, all of those things we can predict well using these models. Next, please. The other thing we did also is that if somebody has a heart problem, you have this blood, the strange thing is heart is immersed in blood. And when a heart attack comes, why a heart attack? There's no blood in the heart. That means there's so much blood that is pushing, but there's no blood coming to the muscles of the heart, because you have small arteries, they're blocked. So they're not getting supply. So these are the arteries we have, and this color tells you amount of stress. That means how much pressure on the tube is. If you have a water hose, right? When you're gardening with a tube, and you can see water going through that, there will be, if there is a kink, then the pressure goes very high. One side it blows up, the other side there's no water coming. And the same thing here. Our blood vessels are just like a garden hose, that if there's, whenever there's light, that means high pressure. That means the person might get heart attack. And here, absolutely blocked vessels. So when a surgeon is doing that, the surgeon needs to know exactly where to open up these things called stents. They're like little cylinders you insert into those things so that the blood can flow well. Now the problem is that to understand how much stress that is there, we need to do this computation. And what they found is this computation, if you want to do in a traditional way, it would take something like 72 hours to understand how much pressure on these blood vessels are. And we did using machine learning, and we can do in 3 seconds. So that means the doctors can actually study the pressure on this particular vessel in time, and therefore the surgeon knows where to clear up these things. For example, here, this is a very stressful position. You need to put a stent here, maybe a stent there, and you can't put too many, of course, depending on how sick the patient is. That we could do because of the machine learning. Next one, please. Okay, I think this is too much for you. I'll skip that slide. Okay, so one of the biggest problems machine learning has, remember, there are two ways of making a computer to behave. One is giving an instruction like how to make a cake, for example. You simply tell procedures and the computer simply follows. The next one is you give examples and you want to learn. We make jokes. How many of you know prime numbers? Everybody should know. So, for example, somebody would say 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. These are examples I told, let's say, my daughter. And immediately she says, oh, 9 must be a prime number, right? This is by examples. Everything going by, kind of odd numbers. Odd numbers seems to be prime numbers. Of course, all prime numbers are odd, except 2, right? So 3 is a prime number, 5 is a prime number, 7 is a prime number. So you must think 9 must be a prime number, right? And this is how machine learning works. It can actually make wrong decisions because the examples you have given basically showed to the computer saying that looks like all odd numbers are prime. It's not. We know that all prime numbers are odd, but not all numbers are prime. So the same, that's what we call is that the data acquired may not be complete. So that means if you have a poor data, your machine learning will be really bad. Unfortunately, there is no mathematical way of showing you have a good data. Only we can do is, statisticians might advise you how to collect good data, but that can also go wrong because any model collection assumes, any data collection assumes a particular model. Our goal is to find the model. We don't know what the model is. Therefore, we don't know how to collect the data. So it's catch-22. So all we believe is that the more data you collect, most likely it is tending to be more complete. So if you have a poor data, machine learning fails spectacularly. As I said, there's no procedure will ever exist. I said much stronger statement, it will never exist. That means there is no way of knowing we have a good data. All we know is we have done the right thing to collect the data, and that's all we can say. Okay, so these days we have collected huge amounts of knowledge over the centuries in all areas of sciences and engineering, economics, social sciences, arts, and we can actually use, and how can we use this information seamlessly with AI? This is a big open question. Again, this knowledge is also not complete. Yeah, for example, if you know quantum mechanics, I mean, you don't know quantum mechanics. Just I want to tell you is that quantum mechanics or general relativity cannot tell dark matter and dark energy. We don't know what makes them. The whole physics, we thought we understood everything, but we don't. There's a huge gap in understanding these things. So the models we have is always going to be incomplete. Okay, you never have a way of knowing whether you have a perfect data, perfect understanding. So all our theories, physics is incomplete. We don't know. Maths well known to be incomplete. That means there is a Gödel's theorem which tells you that you cannot prove all your theorems in a given mathematics, and there's also theorems where you can't prove whether they are false, they are true. You can't, and this is one of the Gödel's theorem, which basically tells you that all these mathematics are incomplete. This is how we have to live with. Okay, next one. Trust and AI security. I told you, if you have a bad data, the behavior will be completely bad. And second thing I told you is that once AI system is built, I cannot tell how good that AI system is. When it's going to make a mistake. If it makes a mistake, how dangerous that mistake is, I would not know. But at the same time, it seems to do better than many humans and seems to do much better than in many situations. And that's why we rely. So for example, today, the whole Google is driven by AI systems. You may not know, it's completely AI-based software. So is Microsoft, so is many Chinese companies. And all the governments applying AI now. So for example, let's say, if you go to a football or a cricket, let's say there may be 100,000 people watching. The AI systems can recognize every one of them. It can pinpoint every one of you by taking your pictures. I don't know whether you ever seen Google Photos. If you look at it and you type one of your relatives' names or something, it will pick up pictures with extremely small only notes is there, and it recognizes you're there in that picture. And that is so scary. If you really think, it is so scary, because they can watch you wherever you are, which is kind of, if the governments are bad, then you have no security. Your life can be threatening. So the AI systems are so powerful, it's so scary. As I said, it's also possible the AI system tell you, you are Mr. Padmini. In fact, you are not, but it recognizes, and the government police comes and puts you in jail, and there's no way you can do anything else. If it is a very draconian government, then that can happen. Again, I would say that when we build software, these are written by humans. That means they do make mistakes. Even though we know perfectly model, we do. So for example, people used to write computer programs to launch satellites. There's a slight bug, and then the satellites, instead of going in a particular orbit, it went to some other orbit completely, because there was a slight error in putting a little comma in the code, a little mistake. So there will be so many bugs in our computer software. So it doesn't mean they are. But what we know is that most of the software we understand well, and potentially these bugs can be found and rectified. But what we can't do is, for AI systems, there is a similar kind of misbehavior. We don't know how to control it, because there is no understanding today how to make them better. So this is a very interesting area of research for future people. Next slide, please. Okay, next one. They're too technical. Okay, maybe next one. Okay. Impact of AI in society. So this is probably a little bit less technical. AI is penetrating just about every field. One of the things you need to know is people say, I'm only interested in mechanical engineering. I don't want to study anything else. But what they don't realize is, today, if you buy a car, good quality car, the cost of the car, nearly 60% is computer software. Only 40% is you're paying for tires, engines, metal, and all that shapes. Everything is, whole aerodynamics of the car is done by computer simulation. Its stability is designed by computer. Its automatic control is done by the computer systems. So computers rule just about every area that I know of, including arts, including music. Even probably very soon, computers will be writing songs as well. You give an idea, it has to be romantic, or it is sad, and then it will write a song for you, completely as good as any human being could ever imagine. AI will replace many jobs. Look, the names I gave you, the jobs that are going to be replaced: engineers, doctors, lawyers, teachers, military applications. They're all going to be taken over by AI. Or at least, previously, if you have 10 doctors, maybe you only need one doctor. Basically, they use AI systems, and maybe one person controlling these AI systems. Already you can see there's amazing tools available on the internet, but one of the things that some of the internet doesn't have is the kind of feedback, understand the individual progress. Some of these AI systems can do that. When a student is taught by a computer assisted system, it actually uses AI tools to recognize the weakness of the student and tell which part and choose teaching appropriately. Like, for example, it understands, this student has a miscomprehension of let's say, prime numbers. It very quickly understands what the student has done a mistake, and develops appropriate teaching material on the fly, just like a human being would have done if you have a personal tutor. You know, for example, if you go to Oxford to study, you have a professor to teach one-to-one. This is the only place where this amazing thing happens. In Oxford, you will have a one-to-one. Sometimes a Nobel laureate will be teaching you at that. I mean, you have to be a genius to get into that kind of luxury, but that's what Oxford is. And some of the AI systems might actually give you that. May not be today, maybe another 5 years, maybe 10 years. It is not that far away as far as I can see. That is possible. You can build teaching assistants exceptionally high quality that understands your strength, your weakness, and then comes a program accelerate. If you're really brilliant in mathematics, it takes you straight into the deep maths. And if you're weak, and it knows exactly at what stage to give you and make you train in that way. Robots can build houses, roads, drive cars, fly aeroplanes, all of these things almost happening even today. How do we manage and engage our society when this becomes a reality? I mean, this is a big issue. Like, you know, if there are no large availability of employment, humans need to be engaged. The question is, engagement means doing a work or performing an act or something that we're trying to do. Right, so this is a big question. We don't know what will happen in the next 20, 30 years. What would be the future would be. The technology is going with such a phenomenal rate that it's going to raise many social issues. Governments don't really know what will happen when this happens. Next, please. So to give an example, when I was a small child, or when I was at school, a lot of people would learn typist. There will be typing jobs will be there, a lot of people. Now, no typist jobs anymore. Now you can actually dictate completely, and the AI system will produce, including correcting your grammar, correcting your spellings, all of those things it does. Right? So already AI is in your iPhone or your smartphones. They do facial recognition, they do the language, they predict text. When you're sending a text message, it tells you what the next word is. Sometimes you're sending something and you don't read what you type, and it sends entirely different message as well, because we haven't read it carefully before we say send it. And I do all the time, and then I realize, oh, this was a mistake, and then send next message. Sometimes the AI system is actually unhelping me because I had to send twice. So in most advanced countries, there are no there are no banks anymore. Everything done cashlessly. I mean, I can see even in India, it's happening a lot. Everybody pays using phone now. So that means you hardly ever need to carry cash with you. You can buy vegetables using your phone. Especially in China, I see all the time they use the phone, including on the street. Somebody selling on a street some food, you pay with your phone, almost no cash. The benefit of that is probably we will eliminate fraud and crime, because as long as cash currency is there, people do wrong things. Anything that is done electronically is documented somewhere, and we can build an AI system to track all the corrupt people easily. At least we can reduce substantially. There was a study a long time ago. If there is no cash-based economy, everything using bank cards or something like that, you can eliminate complete crime, because people can't. If I have notes, bank, currency bills, I can store in my truck. I see many Telugu movies. They show you so much money coming in a big lorry, truck. So that has no value. You need to show money in your card, and if you have it, then we can track them, and we can probably eliminate fraud altogether. Transaction recorded, every transaction can be recorded, and therefore AI system can say this transaction looks very illegal. Let's say, for example, every day I buy some food, right? All of a sudden my transactions show 100 times more, and it tells you there's something strange happening. Okay, all of a sudden they see in my bank account $1 million came in a single transaction, and straight away they catch. So for example, whenever I send money to anyone, we have a system, because it's going from one country to the other. If it's more than $5,000, now I think it's $10,000, immediately there is a flag that goes to the police. Okay, this man transferred $10,000 to this person. They can actually say, okay, it's a brother, he may be helping. And they see, okay, he has done that 10 times in the last 20 years, so it is not exceptional. On the other hand, I have never transmitted, I'm sending 10,000 every time, then it might think, okay, maybe it's a drug deal, or something not natural. So somebody will come and knock the door and will ask you, explain why this transaction took place. You have to give a reason why you sent so much money in such a short period. So this is some of the good things we can do with the computing and AI and communication technologies. Next slide, please. So this is the sad part. I have a fear. When I started computing nearly 40 years ago, people used to say computers will take jobs away, which is true. A lot of typist jobs gone, a lot of banking jobs gone, a lot of administration gone completely. If people used to fill up 1,000 forms, we do all online, all of those things. So a lot of jobs have gone, but the computers also created many jobs. Today they tell me that one of the reasons India is doing so well is because of the computing. We have trained so many people in computing, and they were able to bring a lot of money to the country, both locally and internationally, because the computing created so many new jobs than anybody ever thought. But the problem with AI is that it is trying to replace even these programmers now. I skipped some slides. Foundation models, basically it's a new kind of techniques that they can build themselves all the complex software. So the question is that probably in 20-30 years from now, you don't code anymore. You use existing systems and put them together, and that will be done to some extent automatically. So there will be huge loss of employment in many fields. Engineers, a lot of them use basically, if you want to build a big bridge or something like Nagarjuna Sagar Dam or something, we used to have thousands of engineers used to work and build them. Now one person can just press a button and the whole design will come. And same thing with medical. You have all these general practices. You go there and you put your hand on some of these screens, and it will sense your blood flows, your sugar levels, everything. Straight away it knows what's wrong with you and gives you a treatment. It might even do surgeries. Robots can do surgeries automatically. Even an eye operation is feasible with a robotic, much more precisely, very reliably it can do. So the question is that what do we do in that case? When there are no many, now the earth is so many people, and we need to create them wealth. We humans have to be engaged, otherwise we all become really bad people. We have to be busy to be good persons, and I mean busy in a good way, not in a bad way. So we need to think of what will happen in the future. We need to teach and train our students preparing for this new future. Somehow, we need a quality of life so that there is a harmony in society. AI is currently solving many problems which were thought to be wrong spelling, be impossible, and the AI becoming much more practical, and trend will continue. So, as I told you, the AI systems are already applied in medicine, in engineering, in lots of places. So right now, the whole security system is run by AI systems, face recognition, your mobility. Like if you are carrying a smartphone, they know everything about you. In fact, they can even tell you what you have eaten that day, depending on which restaurant you went to. Okay, they can pinpoint to that level. We need a new way of distributing wealth and make society flourish. These are the wisdom part of the triangle I showed you. That means we have all this wealth created by all of these things. How do we make the society to be happy with that? Next slide, please. I think we're coming. Okay. So what's the future? AI still cannot solve many problems. You know, one thing you should remember, every time we solve a problem, a new problem comes and we don't know how to do it, which is a kind of a good thing. That means it will create new employment, new of thinking, and so on. Quantum computing, probably you heard that word. Quantum computing, if that becomes a reality, it is unbelievable computational power that comes in. So what you can do today in 300 years that will take the computing to finish, you can do it in half a day. So you don't have to wait 300 years. Using the largest computers you have in the world, they can be solved maybe in hours when quantum computer becomes a reality. Right now, quantum computing is very, very far away from reality. But the quantum computing would have a huge impact on AI because AI problems are very complex to train them, and if the quantum computer is there, we can train them incredibly fast. So if you want to be a brilliant person, these are the things you need to know. You need to know mathematics very well, really, really good at maths. And the most important thing is any maths you ever learned should never forget. If you forget anything you learned, that means you wasted that year, right? If you learned calculus and you don't remember calculus 2 years from now, that means you wasted your time. You learned trigonometry and you forgot trigonometry, that means you wasted that part of your life. So anything you learned, even if you're not using it, you have to keep it in your head. Physics makes you fully understand even maths. If you want to be a good mathematician, you need to have a good physics understanding as well. Many times physics explains maths much better than maths itself explains to you. You know, you may not realize that Einstein was able to do such an amazing stuff because he was good at physics and he needed a lot of maths and he learned maths, and he wasn't that great in mathematics, but he could see the meaning of those maths better than any other human being ever born or will ever be born. So that's how physics becomes such an important thing. You never ever, if you have any interest in mathematics, make sure you show same interest in physics. And chemistry is even more complex. Chemistry is a more complex than some of the basic quantum mechanics because chemistry has more particles in it and therefore more complex. Languages, you know, if you know more languages, your brain will become much more developed. People say if you know more than 2 languages, the chance of you getting Alzheimer or dementia is much, much lower. The more languages you know, even when you are at 95, like my mom, you can still run the business. My mother is 92 and she's amazingly good. She's cooking for me every day for the last 3 months and she tells me what I should do every day. And she's very good. She even tells me how to clean something much more effectively than I know. And that's because I think she's kept her mind busy all the time. Sadly, she only speaks Telugu, but that's a counterexample. But the more languages you know, you're better off. And the better you are at languages, you shine much better. Okay? Next slide, please. Just summary, I think. Yes. What's happening in our world is that we're collecting a lot of information. The growth of data is going very high. That means we can use this data to build more complex things. You know, for you, one of the things you have to be thinking is, I have this data, how can I use this data for an application using AI? I think that's becoming current trend now. Everybody starts up a new company because they know that I have this data, I can build this system. So one of my PhD students, we did work on the retina. Like, you know, you look at the picture of your eye using a color photograph, and from that we can predict whether the person has a high blood pressure, whether they have diabetes. We can even predict when they are going to die to some extent. You know, it's not perfect. It tells you the person would, there's a 90% chance the person will have a stroke in the next 5 years. We can predict very, very accurately. We can even tell, looking at the eye, the person will have some damage to the brain, in which case we can recommend them, you go and take an MRI immediately. And we can do that. So you need to think what data we have and how we can apply AI to make use of building more complex systems. Data mining and machine learning tools are required for processing a variety of complex data for aiding in decision making. So I think more and more we will use AI systems in every part of our life. So for example, if you're going to buy a Tesla car, how many of you want to buy a Tesla car? Yeah, that means you are completely relying on AI. Okay? How many of you want to have an iPhone? Yeah, all of you want AI systems. So you can see AI is already playing big role in our lives. Okay, thank you.
I request you to please join on the dais as we proceed with distributing papaya seeds to the students.
Who is 92 years old. For the last 3 months he is spending time with his mother and serving his mother at the village town called Bobli, and we came to know that he is here, and generally he goes and gives talks in IIT Chennai, IIT Mumbai and IIT Delhi. Okay, and he studied in Indian Institute of Science in Bangalore. Okay, after his completion of his engineering in this Kakinada, and now he went to Indian Institute of Science in Bangalore. Imagine 40 years back he must be studying his engineering, and then there is no computers. He was selected as the first 13 members were given computers in Indian Institute of Science in all over India, and he was selected for it because of his best student or whatever it may be. Okay, and he has been, from then he is working on computers. 40 years back, there is no artificial intelligence, no computing, nothing at all. And imagine now you are the students of grade 9 and 10. After 40 years, what is that you are going to do? Okay, this is an imagination of your work today will take you to heights of tomorrow. Okay, it's not just some people must be liking the lecture, some people must not be, children must not be liking the lecture or this thing. But you imagine this 40 years back, he has no idea of computing or computer sciences or anything else. But now without computing there is no life, human life at all. Okay, and imagine how you will be after 40 years with this kind of technology and this thing. It's a very, that means you can, it's a very rare dream. I think you have to imagine yourself and then work for it. Okay? And he is generally gives lectures for IITs, but on our request he has come here and giving a lecture for you. It is that how much you can use it and see that how much you can progress it. Now children, I have asked some 12th class children and other children who has completed our 10th class with us, and most of them are taking artificial intelligence in their engineering, and data science is the two hot subjects which the children are most choosing themselves. And now you're getting a lecture of yourself on artificial intelligence, which should be definitely very much useful for you, I think, whoever are taking choosing it. I don't say that everyone should choose this, but it is your interest and your passion to do whatever you want. But this lecture will be very much quite useful for you to see that how can you pursue the artificial intelligence in the future. Okay, so you must be very lucky enough, and I thank Mr. Rao for sparing his valuable time and coming to our school and giving a talk to you. Okay, thank you.
Prakash Vidyaniketan, and tackling the loopholes was truly interesting. We have learned through all the instances given about the impact of data and artificial intelligence on every sphere of life. You have given us valid questions that need a breakthrough, which fan our flame of curiosity. Your explanation about AI has broadened our understanding and much more. We assure you, sir, that we will inculcate all these values in our life. I would like to thank our beloved director, sir, for organizing this spellbinding session. Last but not the least, I thank all the students for their interactive and enthusiastic participation. Thank you.
Thank you for inviting me to visit your school. I'm most impressed with the quality of facilities, and especially impressed with the interest and emphasis in art and handmade artistic items. I think it's very important for children to not only study sciences, engineering related materials, but they should also enjoy art and culture, because a society without art is a society without soul. And I think it's so nice to see that they love painting, they love culture, because a lot of the painting related to Hindu culture, that is quite impressive. And I'm also quite delighted to see how clean the place is. I think the cleanliness and the condition of the buildings is the first impression I always take, how good the place is. I myself studied at University of Science Bangalore. The people were amazing, but I found they don't have enough money to maintain the campus. A place like University of Science should maintain all their infrastructure, including buildings. The reason I was mentioning is when I see a broken window never fixed for years, it gives you a very depressive feeling. And this is good. This school is amazing. It's in fantastic place, very hygienic. Kids are amazing. They all seem to keep their eyes wide open. Especially when I give a technical talk, it's very hard because I'm a professor of computer science and never probably gave a talk to kids like 10th grade or 11th grade kids. But I thoroughly enjoyed, because some of the kids came and told me how much they enjoyed, and that's what generally makes any academic happy, that they could give a message that they liked. And I think the school is good, and I'm quite surprised they have more than 21 years of experience running a school like this, and I wish them all the best. Thank you.